Hello everyone. For today we are going to solve problem number 138. Copy list with random pointer on LeetCode. So the problem is very simple. So what the problem statement tells with all these words is that we are given a list which is like normal linked list only, except for here we have another pointer that is called random pointer, and this can point to any of the nodes or null pointer. So this is the difference in a normal linked list and this given linked list with random pointers. And what we need to do is we need to exactly make a copy of the original list. So whatever the values they have given, we have to make a duplicate copy of that. So it is as simple as that. But how can we achieve this? So we can't directly return the given head. We need to make a separate copy of this. So copying a linked list is very simple. We make a list given as per the given list. But what the trick here is that here we have also a random pointer. So what we'll do is let's first see how to solve this using brute force. In brute force, what we do is we first create a map, because in order to match the random pointers, as random pointers can point to any node, we can't simply make the list like this, that we first create one then create two and so on. So this will not work here, because when we are trying to point once random, we already would have access to some other element, or you can say rest of the elements. So what we can do is, in these situations we can always use a hash map, where we will have the access of each and every element in just big of one time. So what we'll do is we'll first create a hash map with every node. So suppose we start traversing from here, so we'll take current here, and then we will map this one with new one, you can say, then this two with new two, and then we will traverse this list again, and this time we know that we have access to each and every element, that is we have access to one's new one also, two new two also. So now we'll check where the next pointer is pointing. So it's normal that next pointer will be pointing to next only. So we get hold of this new next and make the links possible. And similarly, we check in the original list where the random of the first list is paused. First node is pointing, or you can say original list is pointing. And using the value in the hash, we link the same node. So let's see example or code that will be more clear. So what we require is, first we require a map of nodes. So we'll declare map node mp. Then what we require is we require some variable to traverse this linked list. So we will make current equals to head. Now while this current is not equal to null, we will traverse this list. And what we need to do is, at each step we need to map this current to a new node. So new node with value that of equal of current only. So current val. So what here new node current val does is, it creates a new node with exact value as current node. Then we need to simply move our current to current next. Now we will again bring our current to head, and we'll again traverse this whole list. So again while current is not equals null. What we'll do is we will now try to change the links. So empty at current. So what this will give us? The new node which was mapped to this current element. So next of this new element should be equal to MP of current next. That means where the next of current was, the new element that was created, we need to map it there. And similarly for random also, MP at current and random. So current element that was made, its random should also point to the random, the node that was mapped to the random of original linked list. And then we simply need to move this current. And what will be our result? Our result will be the new node created for the head. So we simply need to return empty at head. Let's see if it's running. Okay, the sample is here passing. Let's try to submit it. So as you can see, it is getting accepted, but it is not the optimal approach because here we have to use big of n extra space also. The time complexity is big of n because we are traversing the list twice. Let's see if it is possible to reduce this extra space complexity or not. So to reduce this, what we can do is there is a approach to solve this. What we do is, as we know that we require the access to all the elements. So if we go by natural method, this was the best way to do it, like creating a hash. But what else we can do? So we can say it's a trick or you can say it another approach. First we try to add these new elements. So suppose it is 3. Let's take different values to become more clear. 3, 1 and 4. So we create a new node with same value as the original. And this link, we need to change this link. So how to change the links in a linked list? Let's see here. So if we directly change this next, we will lose the access to this element. So what we'll do, we'll first create a new node, then we will link the new nodes next to this current elements next. And now we can free up this next. So now we have created a new node with same value and inserted it in between the original list given. Similarly here we will create one, then first we will link this, then we'll unlink it and link to this. Similarly we'll make 4 here. We will first link this and then unlink this and this. Now we have traversed it once and we have inserted all the links in between here. Next what we can do is, now that we have access to all the new elements, what we can do, we can change the random pointers also. So we again start traversing from this element. We see what is the random of current element pointing to. So random of current element is pointing to null. So if it is null, we simply need to make the random of this point to null. So random of this will point to null. And now we don't need this link, so we need to break it. So let's see. Then we come here. So what's the random of 1 pointing to? So the random of 1 is pointing to 3. So the this new node of random will also point to the next of 3. That means the new node created. So this node's random will point to this 3 only. And next what we need to do, we reach to 4. See that the random of 4 is pointing to null. So the random of new nodes 4 will also point to this null. So now we have linked all the next and random pointers. So now in this step, what we need to do is we need to remove this extra links and add this link back to the original. So what we'll do is, so next of 3 should point to the new of 1. So the next of 1 should point to the new nodes 4. So let's see code that will should get more clear. So let's first reset it. So first we'll check that if this given head is already null or not. So let's check the constraint for that. Okay, the n can be 0, so this node can be a null. So we'll check if head equals null. We simply need to return head because, or we can return null, both will be the same. And if this is not the case, then we need to start our algorithm. What we'll do is we'll first make a variable to traverse this list, then we will traverse while current not equals null. And what we need to do is we need to make a new node. So let's create a temporary node. Now temp will equal to new node with value that will be same as current value. Current val. And now we need to link this into the original list. So what we'll do is we'll first, as seen here, we first need to change this link, the next of new node. So what we'll do is we'll make temp next equal to, so what was the temp next equal to? As you can see here, the temps next should be equal to the next of current. This will be current next. Then the current next will become this temp, and now we can move the current ahead. So what will be the next element? So the now the current next is pointing to the this new value, but originally the current next should be moved to 1. So what we can do is we can either do currents next or we can simply do temp next. So we will do current equals temp next. So now our current will move to 1 here. Okay, so this way we will insert a new node in between every node. So our step 1 is now complete, and now we need to do is we need to add. So what we have done is here is, let's comment it out. So added a new node with value equal to original in between the original list node elements. And now what we need to do is We will move this current back to head. Second step, we will connect random pointers to your copied list. So we will do is while current not equals null. So now we need to current the random pointers. So first we will get hold of the duplicate value. So duplicate value will lie at node. We can call it temp again. So node temp will be, it will be lying just next of the current because we have already added the new elements in between. So this is our new element temp. Now we need to change the random pointers, and for this we will check condition if currents random is pointing to null. If current random is null, then what we need to do is we need to do temp random equal to null, and if it is not pointing to null, then what we need to do is we need to do temp random. Temp random will point to current randoms next because there will be where our node will be present. So what will be the next of, let's see in here, the random of 1 should be 3, but how can we reach 3? So our current is at 1 here, so our current is pointing at 1, so the random of 1 will be pointing at 3. So currents random, and the next of this will be the new node created. So currents randoms next will be the random of the new node created. So in this case we will do temp random equal to current random next. Why we need to check this condition externally explicitly? Because here we are trying to access current random next, and if this is already null, this can cause an error. So we need to handle this case. Now what we need to do is we simply need to move current to the next. So we can say temp next or currents next. So we will do current equals temp next. Our current have moved to one step ahead. So this way, what this loop will do is this will connect all the random pointers. So first we inserted the nodes in between. Now we connected the random pointers also. So now we simply need to break this external links and get our duplicate list. So we'll again move our current to head. Then what we'll do in this step, so what we need to do is here separate the two list, and also we need to get the hold of answer. So we will change here. So now our head, this head is of no use to us, so we can make a, let's create a new variable only. So we'll create a new variable node new head equals, so new head, what will be new head? The new head will be the next of head next. You can see here the new node 3 is simply the next of head. So this is what we need to return at the end. And now we will traverse this while current is not equals null. Then now we need to separate out the lists. So Just like before, we'll get hold of the new variables or new node. So node temp will equals current next. So temp is the new node. And now how can we break this link? So in order to break this link here, let's see, 1 is linked to 3. So we first need to link this. We already got hold of this 3. So we need to link this current next to next. So this is next, or we can say this temp. So temp next. So current next should become this temps next. So this will break from here, and this will again point to the originally, and this temp next, where should this point to? For the temp next should point to, if this value is existing, so this will point to this, and if it is not existing, then this should point to null. So let's see in the code. So first we'll do change the next of current. So current next will become temps next. So now the current next is changed, and now we need to check if the next of next is existing or not. So next of temp. So if there is a next element to temp, because if temp is the last element, so we need to handle that explicitly. So if temp next not equals to null, so if it is not equals null, then we need to do temp next. Where should this point to? Temp next should point to the temp next and the next element of this. So here, this temps next, 3 is next, this should point to 3 next is 1 and its next is 1. So this should point to this. So temps next will become temp next only if this is not null. So this, and if it is null, and then it will simply point to null. This, and next is null, and now we simply need to move our current one step ahead. So as we have already this moved this current, so now current, we can say simply current is current next only, and at the end we need to return the new head. Let's try to run it. Okay, so sample test cases are passing. Now let's try to submit it. So it is getting accepted. So in this way, we need to traverse one more extra time over the loop, but the extra space required is now removed. So time complexity will still be big of n, and the space complexity will be big of 1. So today we've seen the both brute force and optimal approaches. So thank you and see you in the next video.